Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Promotal, Kathmandu, and the Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in your science class, today we are going to start a new lesson. It's magnetism. Okay. Well, let's begin it with a magnet. You all know what is magnet, yes? You all have seen a magnet, isn't it? So if I give you a piece of object, I simply give you a piece of object and ask you find out whether it is a magnet or not. You have to find out. I simply gave you a piece of object, okay, and I asked you to find out whether that object is a magnet or not. How would you do that? How would you do that? Well, it's simple. What would you do? You will try to stick it to some iron object, isn't it? Yes? Okay, that is what we all would do. Normally, that is what people would do. Try to stick it to an iron object. Okay, if it sticks to the iron object, then it is a magnet. If it does not stick to an iron object, then it is not a magnet. Or alternately, what you can do, you can try to bring it closer to an iron nail. Okay, if it attracts the iron nail, then it is a magnet. If it does not, then it is a non-magnet. It is not a magnet. Okay, so basically magnet is any substance that has power of attracting iron pieces toward itself. Any substances that can attract iron objects toward it are called magnet. Okay, and the property of magnet because of which they can attract iron object toward themselves, it is called magnetism. Okay, the property of magnet due to which it attracts other iron objects is called magnetism. Yes. Okay, now here I've shown you some examples of magnets. Okay, now this is a very strong permanent magnet which is made from an element called neodymium. Neodymium magnet looks like steel, isn't it? Yes, but our conventional magnets, they are usually made up of ferroalnico. That means an alloy of iron, nickel and cobalt, or simply alnico. Sorry, what I said. Okay, ferroalnico means iron, aluminium, nickel and cobalt, and simply alnico. Some may use alnico. Alnico means an alloy of aluminium, nickel and cobalt. Okay, the conventional magnets are made up of alnico. Okay, but this is somewhat modern class of magnet which is made up of neodymium. Okay, neodymium have even stronger magnetic properties than iron, nickel and cobalt. Okay, that is why neodymium, it is a rare element as well. Neodymium magnets are very strong. And this magnet is in the shape of a disc. And look at this. This is a natural stone. This is a natural stone which has ability to attract iron objects. Okay, a natural stone which has ability to attract iron objects, and this stone is called lodestone. Okay, this stone is called lodestone. Okay, it is a natural magnet, and it was discovered by Chinese around 800 BC. 800 BC means 800 years before Christ was born. Okay, some documents also claim that lodestone was discovered by Greek shepherd. Okay, anyway, I included whatever is given in your textbook. Okay, so next one, you can see this magnet is in the shape of a horseshoe. Horseshoe means the piece of iron which is kept under the hooves of horse. घोडाको खुरको मुनि जुन आइरन ठोकिन्छ नि, फलाम ठोकिन्छ, त्यसलाई हर्सशू भन्छ है, घोडाको जुत्ता हो। त्यही हर्सशूको शेपको म्याग्नेट चाहिँ horseshoe magnet. Okay, and the most common one, this is the most common magnet of all, isn't it? And you all know about this. It is bar magnet. It is bar magnet. And here you can see this type of magnet you might have got as your toy. Okay, this type of magnet you might have got as your toy. They can be bought in stationery shops as well. Okay, in electronic shop as well. Okay, and this kind of magnet is called ring magnet. Ring magnets. And ring magnets are basically used for making speakers. You know speakers? Yes, have you seen a speaker in your life? Okay, such speakers are usually present in amplifiers. Yes, amplifiers. Okay, in this case here you can see this is a speaker. In your woofer also there is speaker. In your mobile there is speaker. In your TV there is speaker. Okay, whatever device produces sound, they all have speaker, and this is the basic or general structure of speaker. And here at the base of it, this you can see this black colored ring. This is a magnet, a ring magnet. Okay, just like this. Okay, any confusion? Okay, these are some magnets. Okay, how many types of magnets have you seen among them all? Okay, I know you have seen almost all of them except for this neodymium magnet. Okay, anyway, let's go to properties of magnet. Our next topic is properties of magnet. Magnet, what are the properties of magnet? What makes magnet different from others? Okay, the first property is, we have already discussed, a magnet attracts iron, cobalt and nickel. And these substances that are attracted by an by a magnet, sorry, here is a mistake, magnet. Okay, the substances that are attracted by a magnet are also called magnetic substance. You can see here this is a magnet, yes, and iron fillings are kept in the paper. Iron fillings means powder of iron, like very fine pieces of iron. Yes, and when magnet is brought closer to the iron fillings, you can see within its magnetic field the magnet has attracted the iron toward itself. Look at the picture there. The magnet has attracted the iron pieces around it. Yes, okay, so that is the first and basic property of a magnet. Okay, magnet attracts magnetic substances. And what are the magnetic substances? Iron, cobalt and nickel, not others. It does not attract aluminium, gold, silver or any other metals. It only attracts iron, cobalt and nickel. Any confusion? Okay, now let's go to second point. A magnet always has two opposite poles, and these opposite poles are known as north pole and south pole. Even in this diagram you can see N stands for north pole, S stands for south pole. And where do these poles come from? Where do these poles come from? Well, if you suspend a magnet, suspend means hang. If you hang or suspend a magnet so that it can freely rotate, then it always comes to rest pointing to a fixed direction. Okay, it always comes to rest pointing to north and south direction. And you know north and south direction, isn't it? If you face toward if you point your right hand toward the direction sun rises and left hand toward the direction sun sets, then you are facing north direction. Okay, and your backward is facing south direction. Okay, similarly, if you suspend a magnet freely in air, then it always points out to north and south direction. Okay, the end of magnet which points toward north direction is known as north pole. North pole. Okay, and the end of magnet which points towards south direction is known as south pole. North pole and south pole. Okay, so a magnet has two opposite poles. These are north pole and south pole. When a magnet is freely suspended in air, it always points toward north and south direction. The end of magnet that points toward north direction is called north pole, okay, and that points toward south direction is called south pole. Any confusion in second point? Okay. If there are no confusion in second point, let's go to our third point. It says each magnet has its own field around it. That means if I hold a magnet at my home, can you feel its force at your home? Definitely no. No, that is not possible. Or suppose in the ground you have a metal coin, a nickel coin in your pocket. In our school ground, okay, you are sitting at one corner. Suppose this is a ground, you are sitting at this corner of the ground with some nickel coins in your pocket, and I am standing at the opposite corner of the ground, and I brought a magnet with me, and I pointed that magnet toward you. Will it attract the nickel coins in your pocket? Will it simply attract the coins in your pocket toward me? Will it happen? No, that doesn't happen. That doesn't happen. Okay. However, if you bring nickel coil closer to magnet, then definitely the magnet attracts a nickel coil. Yes, but a magnet does not attract to infinite space. Okay. As you move nickel coil farther from magnet, you will start to feel that the force has been decreased, and at some point you will not feel the force of magnet at all. You will not feel it. Okay. So around the magnet, up to what space you can experience the magnetism, you can experience the force of magnet, that space is known as magnetic field. Understood? Around the magnet you can experience the force of magnet only up to certain space, and that space is known as magnetic field. Okay. So see, each magnet has its own field around it. The space around a magnet in which force of the magnet can be felt is called magnetic field. Any confusion? Okay, now point number 4. A magnet has strong magnetic field at the poles and weak at the central part. Okay, here you can see when the iron filings are introduced or sprinkled around the magnet, you can see that most of the iron fields are attracted toward the poles of magnet. Toward the poles of magnet, most of the iron filings are attracted, whereas in the central part, in the middle part, you can see very few amount of iron filings are attracted. Okay, and these white spaces means there are no magnetism in these white spaces at all. Okay. So you can see that a magnet has strong magnetic field at its poles but very weak at the central part. Okay, that is another property of magnet. Understood? See, the first property, iron attracts iron, sorry magnet attracts iron, cobalt and nickel. Yes, magnet attracts iron, cobalt and nickel, and a magnet has a magnetic field around it. Only up to certain space it can attract objects toward it. Okay, and it has strong magnetic fields around the pole but very weak magnetic field at the center. It has strong magnetic fields around the pole and very weak magnetic field at the center. Okay, okay, that much. And then okay, one extra property, it says that when a magnet is suspended freely in air, then it always points toward north and south direction, always. Okay, and the end of magnet which points toward north direction, it is known as north pole, and the end of magnet which points towards south direction, it is known as south pole. Okay, so next point, let's go to the next point, number 5. Okay, have you ever tried this? You suspend or you keep a magnet on the desk Okay, you keep one magnet on the desk and you bring closer to north pole. Suppose in this example you bring closer the north pole of one magnet to south pole of another magnet. What happens? I took this picture from Encyclopedia Britannica. Okay, if you bring north pole of one magnet closer to south pole of another magnet, what happens? Well, they attract, isn't it? They attract. You have done it or not? You surely have done it. Okay, because this is like children's play. We do play with magnet a lot when we are children. Okay, however, if you bring north pole of one magnet to north pole of another magnet, then what happens? What happens when you bring north pole of one magnet to north pole of another magnet? Well, you know it, the magnet repels. The magnet moves away from each other. See the arrow? Okay. In case of unlike poles, magnet attract. In case of like poles, magnet repel. That is also specific property of a magnet. Okay. Okay, see the note. Like poles of magnet repel each other and unlike poles attract each other. That is, if north pole of two magnets are brought together, they repel each other. Similarly, if south pole of two magnets are brought together, then also they repel. That means north pole to north pole repel, south pole to south pole repel, because they are like poles. However, if north pole of one magnet and south pole of another magnet are brought closer, they attract. They attract. Any confusion? Okay. Any confusion up here? Okay, now the last property, number 6. It says when a piece of magnetic substance such as iron is attached to a magnet, it also becomes a magnet. That is, magnetic field is created around the iron piece as well. This property is called magnetic induction. Okay, what you can see, this also you might have experienced. This is a magnet, yes? Okay, this is a magnet. Suppose these are iron pieces. Okay, these are paper clips which are made up of iron. Okay, what happens if you bring one paper clip to another paper clip? Will they attract to each other? No. Will they repel each other? No. Is there any kind of movement between them? No. Is there any interaction between them? No. Well, why is there no interaction? Answer: why is there no interaction? Why don't they attract each other? Why don't they repel each other? Why don't they move in response to each other? Because they don't have magnetism. You heard it? They don't have magnetism. They are not magnets. They are not magnets. They don't have magnetic properties. They don't have magnetism. However, if you bring this iron close to the a magnet, then you know that this iron piece will attach to the magnet. This iron piece will be attracted by the magnet. Okay, definitely if you bring another paper clip to the magnet, then that will also be attracted to the magnet, isn't it? Because magnet attracts iron. But what if you bring it closer to the red paper clip? What happens? Well, when the red paper clip is attached to magnet, in that case the green paper clip will attach to red paper clip as well. See, the green paper clip will attach to red paper clip as well. But if you remove the magnet, if you remove the red paper clip from magnet, then immediately the green paper clip falls down. Immediately the green paper clip falls down. Okay, you know what is happening here? What is happening here? Okay, so when the red paper clip it is attached to magnet, it also becomes a magnet. Okay, when red paper clip is attached to a magnet, it also becomes a magnet. Okay, it also generates its own magnetic field. Okay, and because of that magnetic field, it can attract the green paper clip. Okay, because of the magnetic properties produced or induced in the red clip, it can attract green clip as well. But as soon as you remove the contact between red clip and magnet, then the red clip will no longer be a magnet and green clip will fall down. Understood? Okay, that is what said by this paragraph at this point. So it says, when a piece of magnetic substance such as iron is attached to a magnet, it also becomes a magnet. That is, magnetic field is created around the iron piece as well. This property is called magnetic induction. Okay, any confusion up here? No confusion. If there is no confusion, then okay. Okay, if there is no confusion, then we are going to do only this much for today. This is your introduction class, that's why I need to keep it short. Okay, okay, तिम्रो कुनै पनि लेसनको फर्स्ट क्लास नै 40 मिनेट लिने हो भने तिमीलाई पनि बोर लाग्छ है. Okay, okay, this was for today. In our next class, we will discuss about new topic, molecular theory of magnetism. And actually, up to here, whatever we studied today, up to here, you have already studied it in grade 7, isn't it? You have studied about it all in grade 7, more or less. You have studied in grade 7. Okay, so what we did today was simple revision of whatever you have studied in grade 7. Understood? Okay, so that's all for today. In our next class, we will discuss furthermore. Until then, I'll see you. Thank you, class.